Hello everyone. In today's video I will be going over our 2.1 notes, which covers how to write an equation in standard vertex form if we're given 2 points. I do want to clarify, I always call it vertex form in this class because pretty much everywhere else that's how we refer it to, but the textbook for this course likes to call this form either standard vertex form, or you might even see them call it just standard form. So I just wanted you to just give you a heads up there. If you see those terms, they're talking about this form of the equation. So just to refresh your memories, when we say standard vertex form or just standard form, vertex form, I'm very adamant about this. I call it vertex form. Every teacher and professor I've ever had has called it vertex form, so it just drives me a little nuts that we're now calling it standard vertex form here. But that is y equals a times x minus h squared plus k, that form of the equation, where our vertex is the h comma k. So this is a specific type of problem. I'm going to do 3 examples with you. First example is, let's say we're given that the vertex is 2, 0, and our point is negative 5, 4. And they want us to write the equation in the vertex form. So starting off, we have y equals a times x minus h squared plus k. So we can immediately fill in the h and the k because that comes from our vertex, hk. H is 2 squared, k is 0, so you can write plus 0, but it's kind of pointless to write it. So here's where we're at. Now from here, we cannot leave our equation like this because a has to be known. We have to know what a is. So this is how we can find our a for any problem, by solving it by hand, by using algebra. So that's what the second point is for. We're able to solve for a if we have every other letter known in the equation. So we have a point here, x, y. If we plug in numbers for x and y, we can solve for a and get a. So we have y is 4. A is a, we're trying to find it. X is negative 5 minus 2 squared. So I'm going to put a little explanation over here. Need to find a. Plug in point for x and y, and then solve. For a. So it's just a really nice algebra tactic that we are using here. All right, let's keep solving. So we have 4 equals a. Let's simplify here first. Negative 5 minus 2 is negative 7 squared. And then I'm going to rearrange this because this is weird to write it this way. Negative 7 squared is actually just a positive 49. A, and then solving for a, all we do is divide off the 49 on both sides. 49. A equals 4 over 49. Not a pretty number, but it is our answer. So now we can substitute it back in. So this was our equation almost. So now we're going to take this equation, and now we have y equals 4 over 49 x minus 2 squared. That is the full equation for these 2 points. For our given points, the vertex is positive 2, 0, and then negative 5, 4 is a point on this graph. All right, let's look at another example. I'm going to throw 2 more at you. All right, for our next example, let's say the vertex is -3, -4, and our given point is 5, 2. Reminder, that means that h is -3, k is -4, x is 5, and y is 2. Now that you understand the process a bit more, I'm going to straight up plug all of these in from the get-go and then solve for a and then put it all together. So we have, I'll write it out one good time, why not? Y equals a times x minus h squared plus k, that's the original equation. Y is 2, a we don't know, we're trying to find it. X is 5, h is -3 squared, plus k is -4. Simplify this down. 5 minus -3, this becomes a plus. So this becomes 5 plus 3, which is 8 squared minus 4. 8 squared is 64. And then minus 4. Remember, this is multiplication. I really should have rewritten this as 64a if I was thinking ahead. So I can't actually subtract these. I'm going to add the 4 over here. 6 equals 64a. Last thing we need to do is divide off the 64 on both sides to get the a. And I can simplify this down. I can divide both of these by 2. So that leaves me with 3 over 32. Now let's put it all together. So for our final answer, we have y equals a is 3 over 32 times x. And then we have minus h is -3 squared, and then k is -4. So let's write that as -4. And then to fully simplify it, we need to make that x plus 3 squared minus 4. That is the full equation for our problem. And a reminder, in your equation, you will have x and y left unfilled because that's how an equation works. You have to have the x and the y. The other letters need to have something in their place. One more example. Let's say for our third example that our vertex is -2, 3, and our given point is 121. So for our vertex, h is -2, k is 3, our point, x is 1, y is 21. Again, the starting general form is y equals a times x minus h squared plus k. And now we'll fill in what we can. Y is 21. A is a, we're looking for it. X is 1 minus h is -2 squared. K is 3, so plus 3. This becomes 1 plus 2, which is 3. So we have 3 squared plus 3. 21 equals, I'm going to switch these. This is going to become 9a plus 3. Make sure you're careful when you're writing 9 and a together, because quickly you can write your a to make it look like a 9 or vice versa. I'm going to subtract the 3 on both sides. That gives me 18. And then dividing off the 9, a is 2. So now we put it all together to get our answer. We have y equals a is 2 times x, and then we have minus h is -2 squared plus k is 3. Again, leave the x and y as is. I'm going to simplify this down once more. This is x plus 2 squared plus 3. And that is our final answer. Alright, that is all that I had for this video. If you have any additional questions, feel free to reach out to me via email or when you see me in person. I do want to make a quick note on the homework assignment. It's basically just you doing this on repeat. I believe the book calls this form, it's either standard, I believe it's called standard form in the book. This is what they're talking about here, is this vertex form that we're referring to here. So if you have any additional questions beyond that, feel free to get a hold of me. Otherwise, I will see you guys later. Bye.